Okay, we got another minute. So while I've got a minute, I just want a quick update on my presentation from the August ONI, which was on approval voting. St. Louis did successfully pass their approval voting ballot measure, so they'll be using approval voting in St. Louis in the near future, and it was already passed in Fargo, so that's 2 cities down, and the Center for Election Science is continuing to expand and try to find other cities to partner with to bring that to other cities. So keep an eye out for that in the future in the real news, I'm sure. All right, and with that, it is 3:30, so I'm gonna go ahead and get started. Today I'm talking about all of the fair dice. By dice, I mean, dice, 6-sided dice. So fun facts, dice predate recorded human history, so we're not exactly sure when they were invented. It was a really, really long time ago. The first dice were made from bone, and I don't mean that they took bone and cut it into little cubes. I mean they took it's called a talus. It's a bone from most mammals, hoofed mammals in particular. It's got 4 kind of squarish sides and then 2 sides that are kind of rounded that it won't sit on, and you just mark the 4 flat-ish sides and toss them in the air and see what the gods want. And that was the original use for dice. It was called claromancy, using dice for divination. What's important about those dice is they weren't fair. There was not a 1 in 4 chance of getting each of the 4 sides. For fair dice, those were developed for gambling. Gambling is why we have dice. You can go, Vegas spends a lot of money now to make sure that their dice are as fair as can possibly be. They drilled the pips, the little black dots, they make sure that those are made of a substance with the exact same density as the white stuff and the holes are filled perfectly, machine precision. They only use them for a little while because they get dented. They are incredibly fair, but those dice are only 6-sided. This is the kind of die you're probably thinking of. This is not a Vegas die. This is just something I had lying around the house. Oh, my camera's off? Okay, I will want to turn my camera on for the future and so I can show off some other things I've got, and now I can't find the button. There we go. Here I am. Start video. Is that working now? Okay, now it's working. Okay. All right, so yeah, I have that lying around. This is probably what you think of when someone says die. These are easy to make. If you've got a block of material, you can cut it up very easily and you'll have very little waste. Probably one reason why they're most popular. But if you're a nerd like me, you think of dice, you think of these. This Dungeons and Dragons, other role-playing games like to use dice of a bunch of different sizes, a bunch of different shapes. These 5 here, these are the Platonic solids, which have also been known of since before recorded history. Here's a 20-sided die from the Ptolemaic Roman period, created sometime between 200 BC and 200 AD. It's inscribed with the first 20 letters of the Roman alphabet. These dice are fair. And you're thinking, okay, we've got these 5 Platonic solids, we've got 5 fair dice, but we've also got this guy. If you've played some RPGs, use just this die. This is a 10-sided die, and this is not a Pythagorean solid, not Pythagorean, Platonic, not a Platonic solid. The Platonic solids they're made of equally sized regular shapes, regular triangles, regular squares, regular pentagons. This is a weird sort of kite-shaped thing. Those aren't regular, but this is still a fair die. So the question you might be asking yourself is, what makes a fair die? Because they also sell these dice. On the left there, that's a 5-sided die. It's got 2 triangles and 3 sort of rectangular shapes. I got a 7-sided die. In the middle is a 100-sided die. You might have seen these. This isn't a fair die. But what does that mean? What shapes actually can be fair dice? And what you're looking for a fair die is you need each face to have an equivalent relationship with the center of mass. So now we're getting into geometry here. All of the faces are going to have to be the same shape for that to be possible, but they also need to be equidistant from and in equal relationship with that center of mass. And mathematically, what that's referred to as is phase transitivity, or isohedral, an isohedral polytope. So if you think of like this little guy here, and I'm not showing my picture to me, so I can't make sure that I want to see me so I know what I look like. There I am. All right. I need to know that I'm seeing. So like if I hold this up like that, ignore the dots, but memorize where the square is. I can turn the die and it fills the exact same, that face fills the exact same square in the exact same way. Along any rotation that I make. So that's phase transitivity. And that's also true for all of the Platonic solids. I'll just grab one here. Like here's my blue D20, like that triangle there, and I can rotate it. And I gotta like return it a little bit, and it fills the exact same triangle. And that also works for the 10-sided die, which I have misplaced. You've got your little kite shape, and you can rotate it, and it fills the exact same kite shape. There are lots of different isohedral shapes, though, that don't work as dice. Here's an example of one that I pulled off Wikipedia. This thing is made of 12 equilateral triangles, but if you tried to roll that, it wouldn't sit on the table. So there are a few restrictions. You can't use just any isohedral shape. That one would, so you want convex isohedral shapes. Also, some shapes, they'll land in such a way so that it'll be flat on the bottom and it will sit on the table, but then the part on top won't have a flat side. So it gets kind of awkward. Sometimes you're reading like across an edge or on a vertex. You actually have this problem with the four-sided die. It sits point up, makes it hard to read. You can still use it as dice. They're just a little awkward sometimes. So what kinds of shapes have this property that aren't commonly seen in tabletop role-playing games already? Here I've got a 14-sided die and a 16-sided die. The left one is that's a trapezohedral trapezohedral shape. God damn it, I still can't say it. Okay, and that's that kite shape that you see on the 10-sided die. It's the same sort of idea. You've got that irregular, not equally shaped four-sided shape, and you can make any multiple of 2 number of faces. You can make a die with that. This 14-sided one I've got is labeled with the 7 days of the week twice. Might be handy if you're generating a random day of the week. I don't know when you do that. Another fun fact, though, is that our good old 6-sided cube is a trapezohedral. You can stretch these squares out and make them a much more irregular 4-sided shape, and it's still a fair die, and it's still it falls in that trapezohedral regime. And the die pyramids, I've got a 16-sided one there. I'm a computer programmer. Powers of 2 are just really great numbers. And you can do that same thing, any multiple of 2, although if it's not a multiple of 4, you end up with the top side is kind of hard to read. The 16 is fine, but if you did like a 14-sided die as a die pyramid, you'd be reading across an edge and be a mess. And similar to how the D6 is the trapezoid, the D8 is a die pyramid. You can see it's got 2 square pyramids. And that's how you make those. And there's an infinite number of these. You can actually buy a 50-sided, I think it's a trapezoid, I can never say this word, trapezohedra. You can buy a 50-sided one. I think that's the largest one that's available commercially. But infinite sets are kind of eh. What about a more interesting limited set, the Catalan solids? These are great. These are my favorite shapes of dice because they're not the Platonic solids. They're not from these infinite sets. They're all like unique and special, but they're all face symmetric. I've got here on the left a 30-sided die and on the right a 24-sided die. And let's see, I need to share a different screen because I found while I was researching this talk, someone had already made a really excellent website. If I can find where I put it. Well, we'll just share this whole screen. We'll figure it out that way. Darn it. My apologies. Technical difficulties. Where did that window go? Please hold. I'm just reopening. Just share that. Okay. Found this really great website. It should be visible now. We good? Okay. Someone made a website that can show all of these. He's got a page for Platonic solids, and you can click and drag these things around. You can see how all of these look. But I want to show you all the Catalan solids. I'll just skim through these real quick. So they've got cool names. This is a triaxis tetrahedron, which is if you took a tetrahedron, you divided each face into 3 parts. But that's got just 12 sides. That's not very exciting. That's not a number. We already have a 12-sided die. We've got a dodecahedron already. We've got different kinds of dodecahedrons, though. This is a rhombic dodecahedron. It's still got 12 sides, but it looks kind of neat. Tetraxis tetrahedron. This is the 24-sided die. This is the one that I already have one to show you. There's he glows in the dark as well, so he's kind of fun. And again, we're just going through these real quick. Hope everyone gets to see them. If you have a favorite, let me know in chat. Triaxis octahedron. So an 8-sided die, cut each face into 3. You can kind of see where the naming conventions go. Kind of long and skinny to try to fit numbers onto. I can see why they use a normal one. Deltoidal icosatetrahedron. It's a 24-sided die, but it's got a funky shape. We couldn't, name it by dividing up something else. Looks kind of neat though. I think you can buy these as well. Pentagonal icosatetrahedron, again, 24, just another different shape. Neat little pentagons though. Pentagonal icosatetrahedron, Levo. So it's a 24-sided die, and it's got this shape, and they kind of spin counterclockwise, and there's its partner, which spins the other way, which might be not in the next in the list, but it's on the later page. Anyway, this is a triacontahedron, a 30-sided die. That's like the black one that I had, just like that guy. We're getting to the good ones. But 30, that's interesting because like there isn't a Platonic solid that has that number. 24, I guess, as well. 24 or the 30. We've got a 60 coming up. Very exciting. Here, pentaxis dodecahedron. This is a 12-sided die cut in 5, so that's got 60 faces. Very nice. Those are also available commercially. Triaxis icosahedron. Almost done. Don't worry. There's only like 13 of these. Fun fact, these were not really discovered or named until the 1600s, although they were sort of, the first ones were identified in like 400 BC. They just couldn't quite figure them all out. One more, and then the next one's actually my favorite. This is the disdiaxis triacontahedron. This is the last one on this list. So this thing is great. It's got 120 sides, and they are available commercially. This really is the whole reason I made this talk up, because I wanted to talk about this die. I love this die. I'm gonna stop this share and go back to my slides now. I love this die. It's huge, first of all. You cannot have a die with more numbers unless you go into those boring infinite set ones. And those get they're just really ugly after a while. They're just a disc or something like that. This is just so convenient, so friendly, so nice. All right, I'll stop talking about how much I love that guy. So there are a couple other possibilities for dice. You can pick a couple of sides and just not use them. Like this is a 3-sided die. You can't make a fair shape with 3 sides, but you can fake it because you can round off some of the edges and it'll stand around. It won't stand on them, so it'll just fall over. Another common example, dreidel. A non-paid advertisement. So I keep saying you can buy these things online. These are the guys that sell them. These guys will sell you a 120-sided die. Among a bunch of other fun stuff, they have a 48 and sets of things. And how am I doing on time? 3:45. Mine says 44. I have 1 minute for more fun facts. All right, so I just want to talk a little bit more about the 120-sided die with my last minute here. So not only does each opposite face add up to 121, so the one is opposite the 120, as you would expect from any good die, but the sum of all the numbers around any vertex are the same. So there are 3 different kinds of vertices, ones with 10 per, ones with 4 per, and ones with 6 per. And the sum around each 6 is the same, around each 4 is the same, around each 10 is the same. They wrote a computer program to try to find those, and they were just about to give up, like they were about to halt the program because they weren't sure it existed when it spit out this result. Really fun. They also did the same thing for smaller dice, and so you can get even fairer dice from these people. The standard D12 could be fairer by changing the arrangement of numbers, getting each vertex fair. Just fun stuff like that. They're good people. They're not paying me for this. That's where I got this, and I love it. I would sleep with it under my pillow if it weren't so big and hard. And now I am over time. If there are any questions, I'll take them in chat. Thank you for playing. I do have 5 minutes for Q&A. Let me take a look at the chat and see if anyone said anything. I can rattle off the rest, but I felt like it was running long. The 30-sided die is pretty pretty. Paper, you can come see, well, not now, there's a plague, but you can come and see my 14 and 16-sided dice. You know where I live. Oh yeah, I guess I could try to roll it. Let's see, can I get the table here? We can see how well this rolls. It is the roundest die. Since it's so large, like those infinite sets of dice can be very round, but they don't fill a sphere as well as the 120-sided die does. It is the roundest die you can have that's fair. You can do all of D&D. Since it's the number of faces it has is a multiple of 4, 6, 8, 12, and 20. You could use just this die to play D&D. It would take a lot longer. Also, I don't know how good your modular arithmetic is. I've got some more fun facts. The Egyptian game of Senet used a set of 4 2-sided dice. So coins, you just flip 4 coins and it tells you how far you can move your things. Although if all 4 of them came up 1, they were just 0 and 1. If all 4 of them came up 1, you got 5 moves. Very exciting. Senet, Senet, S-E-N-E-T. I'm not sure if I'm pronouncing it right, but the rules have been lost to time. They were written on something that decayed, I guess. But you can buy game sets for it now with the rules as best as they've been able to be reconstructed by professional archaeologists and game players. I hear it's not like boring or anything too. It's like as fun as Parcheesi. It's like a precursor to Parcheesi. All right, I've got 2 more minutes, right? Yeah. I've got some other dice I just want to show off. These aren't even like, really, it's not really about fair dice. They're all 6 sides. These are Fisherman dice. Look at those numbers. Don't take these to Vegas, they'll shoot you. But I swear, like it has the exact same probability distribution as 2 normal 6-sided dice. If you don't believe me, write out the truth table, do the math yourself. But I love that 8. And the first time I was playing D&D with these and I got it, it was a great 20-minute diversion where I said, no, I'm not cheating, I swear. And finally, I've got a set of non-transitive dice. I had to make these with a little like die blanks and stickers. So it's a little messy because my handwriting was a mess and the ink wasn't dry when I threw them in my bag. But this is fun because the yellow die will roll higher than the green die 5 times out of 9. The red die higher than the yellow die, and the green die higher than the red die, which doesn't feel like it should be possible, but through the magic of mathematics, you can make that happen. Allegedly, George Soros has a set of these, I think in copper, silver, and gold, and he like offers to play, hey, pick a die, and then I'll pick a die, and winner wins $100 from the other. Don't take him up on that. 1, he's got enough money. 2, it's not a fair game. Allegedly, when he tried this on Bill Gates said, no, that's okay, you pick first. Because if you know which one the other one's playing, you can get the advantage. All right, now I am almost certainly at time. I'm also out of fun facts. Thank you very much.